Okay, hello everybody. My name is Lavakumar, and I'm going to speak on JavaScript static analysis using IronWASP. I'll give you a quick introduction about myself. I've been working as a pen tester for about 5 years. I do a lot of security research. I've not done any last year, but I was doing it before that. I found a Flash zero day, a couple of 0 days, one with web application firewall bypassing. I found a bunch of attack techniques on HTML5. And then I run a site called as andlabs.org where I put most of my research material. And I recently started html5security.org, which is like a repository of all HTML5 security resources. And I also write a lot of code. I started doing this quite recently, probably the last 2 years. And you can, IronWASP is the software that's the most recent, and that's what I'm going to speak about here as well. And my favorite is Ravan. It's a distributed password cracking system written entirely in JavaScript. I think that's pretty cool. Right, and I've been a speaker in a few conferences as well, so that's pretty much it about me. And before I probably begin, it would be a good idea to get an understanding of the crowd here. So, if there are any web application pen testers in the audience. Okay, cool. And any developers, JavaScript developers, or somebody to do with application security? Okay, nice. So you would, probably find this talk to be, a little bit more useful than the others. Okay, so I'm going to begin my talk with explaining what cross-site scripting is, and it is very important that you, get this thing understood properly. So what I'm going to do is I'm going to spend the next 30 minutes explaining the basics and the intricacies of JavaScript. Cross-site scripting, right? Anybody else already know what cross-site scripting is? Right? Everybody else does. Okay, fine. So probably then I wouldn't go into the details. What I'll do is I'll quickly give you a simple a description of what is perceived to be cross-site scripting, right? Your browser sends a request to the server, and one of the parameters has some HTML or JavaScript in that. And what the server does is it returns, or rather it includes that specific user-entered content in the HTML of the response, which leads to script execution, which is what is called as cross-site scripting. And because it usually works this way, it is perceived to be a server-side vulnerability. In the sense, it is a server which is taking the user input and it is putting it back in the response. So when you're looking at fixing this vulnerability, it has to be fixed in the server, right? Because server is what is actually screwing things up here. But then that is not really the case. You also have something called as a DOM-based XSS, and this is XSS fully on the client side. The server really doesn't come into the picture. So to explain this, what I'm going to do is I'll show you, guys, a simple demo. Right, this is a simple HTML page. So what I'm going to do is I'll type in a cross-site scripting payload. A payload that we have all come to appreciate with time, which is the alert box, right? So I put in alert 1, and that command actually gets executed by the browser, right? So let's actually see what happened and how this alert 1 got executed. So this is a pretty simple HTML file. It's got a script tag with just 2 lines of JavaScript in it, and the line number 1 is accessing a property called as location.hash, right? And location.hash, this section of your URL is what is called as location.hash, right? So if I go into my console, yeah, location.hash gives me alert 1. So anything that comes after the hash will be the location.hash. And what I'm doing is I say slice 1, so I just strip off the first character and I assign it to a variable, and then I put this variable in the eval command. Eval is a JavaScript function which will execute anything which is put inside it, right? So what this is basically doing is when the page loads, it takes whatever is available after the location.hash value and it executes it. And this is, I can send this URL to somebody and they'll execute JavaScript on their browser, and the whole attack would have happened on the client side. This request does, this payload does not even go to the server, right? So since this is a problem on the client side, you would have to detect this on the client side. Fixing this is also on the client side, but we would be focused on detecting these vulnerabilities in this specific talk. So when it comes down to detecting DOM-based XSS, one big advantage we have is that we have the entire source code of the client-side script, right? Because JavaScript is not a compiled language, so you have the entire source code. So you can look at the source code, you can analyze it, and you can actually figure out if there's a possibility for a vulnerability, right? And when you're doing static analysis with JavaScript for DOM-based XSS, there are two things that you would have to look for. One is called as a source, the other one is called as a sink. They're called as DOM-based XSS source and DOM-based XSS sink. Now, any parameter in the page which can be controlled by an external party, or rather any parameter in the page which was not sent directly by the server, is called as a source. For example, in this specific case, location.hash is a source. In fact, the whole location property itself is a source, because this property, the value of this property can be controlled by an external entity. Because by sending you an URL, I can control the value which is stored inside the location object, right? So this is the source, and I've got an example for this here. Okay, so any DOM property that can be influenced by the attackers is what is called as the source, and DOM properties, JavaScript functions, or any other client-side entity that can lead to or influence JavaScript code execution is what is called as the sink. In this case, eval was the sink, right? Because eval was actually executing JavaScript code, so that is called a sink. There are a bunch of other sinks as well. I've classified them here. Okay, so these are the different types of sources. You have location-based source, client-side storage source, navigation-based, and cross-domain. I'm not sure if I should go into the details of each of these. I've like put up a list, segregated by categories. You could probably look at the slides and you can refer to these. But all of these properties can be influenced by an external person, right? And in sinks again, I've categorized them under 4 categories, and I've put up a list of a bunch of properties under each of those categories. Again, this is available in the slide deck, so probably you can look at it and make a note of it. Right. So now that we have established what a DOM-based XSS is, what is the source, what is the sink, and how a DOM-based XSS actually happens. The DOM-based XSS happens when a source leads into a sink, right? When a property that is controlled by an external party is executed. The property that is controlled is the source, and the one that does the execution is the sink. So when a source is executed by a sink, you have a DOM-based XSS, right? And when it comes to identifying DOM-based XSS, what you would have to do is, when you have your JavaScript code, you have to first identify all the sources in your JavaScript code, and then you have to identify the sinks in your JavaScript code, and then you have to look for sections where the source gets assigned into a sink, right? Once you do this mapping, then you can either say if there is a DOM-based XSS on that specific site, or there is no DOM-based XSS. If no source is being assigned to a sink, then you don't really have a trouble with DOM-based XSS on that specific web application. Right. So to show how this whole static analysis thing works, what I'm going to do is I'm going to show you a demo with the IronWASP, the tool that I've written for doing the static analysis. Right, so this was IronWASP. I spoke about it about 3 months back, and then I finally managed to release it sometime, 3 weeks back. And this is a complete platform for doing web application testing. You have everything from automated scanning to integrated scripting shells and stuff like that. It's a pretty powerful tool. And in this specific talk, we're going to focus on one section of the tool, which is the JavaScript static analyzer. Now what I'll do is I'll go to this example, the one where we did see a DOM-based XSS issue. I'll copy the source. I'll put it in the static analyzing engine. and I'll do a trace. Now you can say you can immediately see that it highlights these lines, with different colors. So if you look at the top right corner, you can actually see what those different colors would mean. If there is a source discovered on a specific line of JavaScript, that line would be highlighted in orange. If there is a sink in a specific line, it would be highlighted in pink. If a specific line, if there's a property which is both a source and a sink, there are a few JavaScript properties which can be a source, they can also be a sink, right? So those are highlighted in, I don't know what this is maroon or whatever, right? And if there is a line where a source is actually being assigned to a sink, that is the line in which the actual vulnerability exists, then that line is highlighted in red. So here you can see that the first line is being highlighted in maroon because location.hash is being called, and location.hash is both the source as well as a sink. So this line is highlighted in maroon, and this value is being assigned to a variable called as L. And in the next line, I'm calling eval on L. Eval is a DOM-based XSS sink, and since L is a source, and since the source is being passed to a sink here, this line is highlighted in red. And it tells you that this is the line where you actually have the DOM-based XSS, right? And so this is what it pretty much comes down to in its most simplest form, right? When you have a two-line JavaScript code, this is what the tool will let you do. It would highlight the interesting sections of the script, and it will tell you which section has is important in which context. And it's got a very simple to access configuration menu. So these are the predefined list of sources and sinks, right? It does the highlighting based on the information which is put into this list. So these are the list of sources. You can see location is available here, hash is also available here, and eval is available here, right? So if you have your own list of sources and sinks, perhaps you can extend this list, right? And I'll show you how and where that would actually come into the picture. Right, now this was a very, very simple example. Does anybody have any questions this far? Right, okay. Yes. I'm sorry, could you? Mm-hmm. Yes, you would still see it because you're just looking at the source code. Absolutely, yeah. I mean, this just makes the process of identifying issues easier. It doesn't. The line that it highlights in red, it's just an indication. This could actually be a false positive. So that part has to be covered manually, right? All right. Okay, so now that was a very simple example. I just had 2 lines of code. What I'll do is I'll go on to a slightly complex example. This is a page which is again vulnerable to DOM-based XSS, and we look at the source code of that. You can see that the JavaScript code here is a little bit longer, so I'm going to copy that. I'm going to paste it here. Okay, so it has done a trace again, and you can see that there are a few lines which are not highlighted at all. These are lines which do not have anything interesting in them. They don't have a source, they don't have a sink, right? So what you can do is you can just unclick this, so those things go away. So you don't have that noise distracting your actual audit. So you only get to focus on things which are interesting to you. Okay, and okay, one thing to be observed here is can you guys spot something weird about the sink in this case? Okay. I'm sorry? With the colors on, it's difficult to read? Okay, yeah, I kind of can imagine that. Well, anyway, then I'll tell you what's going on. The last line, the sink is a function called as S, right? There's a function called as S, and a variable called as L is passed as an input to it. Right now, S is a function which is not it's not a regular JavaScript function. So it is not it's not a sink by any means. But what actually happens is, in this line, I'm declaring eval is equal to S, right? And 2 lines later, I'm calling S, which would actually be eval, right? So what this tool actually does is, anytime there is a variable declared somewhere, it makes a note of that, and it checks for that variable as well. So even if there was an eval being called or an s being called, it would equate both to eval, right? So that is something which the static analyzer can do. Mm-hmm. Yep, I'll come to that in the last demo, right? Because that's definitely a real life scenario, right? So I'll come to that in the very end. Okay, so yeah, so basically this keeps a track of all variables that have been declared, all variables that have been tainted, and it checks for those variables, in the entire JavaScript program. Now, JavaScript by itself is a very, very flexible language. It's probably the most flexible language available. Location.hash will basically get you the hash property of the location object, right? And okay, let me make the font a little bigger. And in most programming languages, this is probably the only way in which you can access a property. But JavaScript is not most programming languages. So what you can do is, you can access the same property this way as well. Because in JavaScript, the whole object structure is stored in the form of a hash. So you can refer to a property in an object this way as well. What you can also do is, you can store hash as a regular text, and then you can say location bracket a, which would be equivalent to location bracket hash, which is equivalent to location dot hash, right? So you have three different ways. This is just an example. There are a lot of other ways by which you can represent the same property. So you have different ways of representing the same thing in JavaScript, and IronWASP basically takes all of this into account, right? So it factors in for all these eccentricities of JavaScript. So I'll show you a simple example. Okay, so here, when I do a trace, this is the line where you have location.hash being assigned. And when I do a trace, that is the line which is being highlighted in purple. Now what I'll do is, I've now changed it into this format. You can see that it is still being highlighted, right? Now what I'll do is, I'll declare a variable called as xx, where I'll store the string value hash, and here I'll say location xx, and it'll still get it, right? So whenever you declare a string in JavaScript, it keeps a track of all strings that have been declared. And if these strings are being used anywhere as property, parameters, then it'll check for that, and it'll figure out if this property is actually a source or a sink, right? You might not come across these representations that often, because programmers are not trying to write difficult, JavaScript code. They're just getting their job done. But if somebody has a weird programming practice, then this thing will probably cover it. Yes. No, if it is obfuscated or compressed, then this will pretty much give up. I thought about it, and my rationale for not supporting it is because this is for identifying vulnerabilities in regular sites, and they usually don't obfuscate it. It's only malware which keeps obfuscating its JavaScript. I don't know. I mean, Google's. I don't really think you can analyze it anyway. I mean, they are pretty tough to read. I don't know. I mean, if you're looking at JavaScript which is compressed, which could be done for performance reasons, then probably you can uncompress it with a JavaScript library, and then you could put the uncompressed code here. But off the shelf, it doesn't support compressed JavaScript. All right. I don't know. I mean, at this point of time, I'm looking at making this accurate for regular JavaScript. because that itself is an uphill task. I've got a long way to go. So probably once I reach that stage, I'll start supporting crazy JavaScript as well. But I don't see that happening for some time now.
Is this an open source?
Yeah, it's open source. The whole source code is on GitHub. Okay. So this was, these were some of the features available in the analysis engine. Now I'll move on to the next example. Right. So till now, the examples that we were looking at, they were just a bunch of JavaScript, series of JavaScript lines. There was no functions being declared, nothing of that sort. Now, let's look at a page which is also vulnerable to DOM-based XSS, but then it's a little different than the other code. Can you guys read the code here? Okay, cool. So now what is happening is there is a function being declared called as getHash, and this function, it gets location.hash and it returns that value, right? And here you have a variable h which stores the return value of getHash, and that variable is sent into eval. Okay. So now let me copy this thing. I'll put it here and do a trace. Okay. Now what you can see is it has highlighted lines 2 and 3. Where the location value is being taken and it is stored in a variable and the value is being returned. It has highlighted those in maroon, and then down here it is highlighting the eval command in pink because it is a sync, right? But then there is no actual highlighting in red, which should have happened because this page is vulnerable to DOM-based XSS, because when it says get hash here, what it is actually getting is the location value. Now, this is the part where you would have to do a bit of work. Because currently this section I have not automated yet. So what you would have to do is when you're doing an analysis during an assessment, whenever you see a thing being highlighted, and if you see the return variable of a function is highlighted as a source or a sink, right? So then what you would have to do is make a note of that specific function. Like in this case, this function returns location.hash, which is a source and a sink as well. So what I'll do is I'll go to my config, and there's an option which says source returning methods. So these are methods which return source as a return value, and I'll say getHash is a method which returns source, right? Because getHash is the name of that specific function. So what I've done is I've just updated my list of DOM-based XSS source and sink, saying that this method returns source, and now I'll do a trace again. Now you can see that this line is being highlighted in red, and this line where the function is called and the source is taken in, that is highlighted in orange, like it is supposed to, right? So this is something you would have to do when you're doing a regular assessment, because most of the code is going to be split across different functions. So anytime you see a function returning a source, that would be highlighted. You see the return line being highlighted. You can immediately add that specific function to the configuration list here, which is actually pretty easy to do. It's just one click away. You do that and you do a trace again, and that thing would be taken into account for, right? And you can, at any point of the testing, you can say reset to default, and it will go back to the default set of source and sinks. So reverting back the configuration is also pretty easy. Yes. Mm-hmm. Yes. Yeah. See, because it's very similar to this list. So you can just go and keep typing stuff, one per line. Is that what you are asking for?
No, the first line itself, can I give, let's say, one?
Ah, no. You mean like a series of things in one single thing? It doesn't read it that way. It looks for a different value in each row. Do you have a specific use case for putting everything in a single line? Is it like easy to copy paste? Or?
Where, see, here you have actually identified a getHash function.
Mm-hmm.
Returning that variable, right?
Mm-hmm.
And so consider I have found similar functions more than once.
Okay, right.
So in that case, do I have to write that many number of lines here? Or if I just identify that many functions, I can just put it in one line?
Yes, you could, but that takes slightly little amount of work than putting them in different lines, but currently it doesn't support it that way. So yeah, so probably you could use a one-liner Python, because this thing has got a scripting shell as well. You can script in Python or Ruby, so you can write a one-liner Python code which will replace comma. No, that wouldn't work, because you have to click individually on every. Yeah, you have to click individually on every single thing and do it. So yeah, it'll take a bit of work. Sorry about that. Okay. So that was updating the configuration to take into account scenarios where there is a different function which returns the source, and there is a similar example for sync as well. Now this again is a page vulnerable to DOM-based XSS, and this is the code here, and you can see that this piece of code returns location. Now in this context we are considering location as a sink, and this location is being assigned the property name. Window.name is a DOM-based XSS source, right? So this has DOM-based XSS, so when you do an analysis this line must be highlighted in red, right? So let's try doing that. Right. So you can see that there are no lines highlighted in red because this function is declared separately, and this function returns the sync, the get location function. So what I'll do is I'll go into the configuration, and in sync returning methods I'll say get location, and I'll do a trace. So now you can see that the actual vulnerable line is highlighted in red, right? Okay, so I've got a few more, use cases which are similar to this.
Do you have any plans to add like a passive scanning kind of feature where you would alert the event you saw sources online as you were using a proxy feature? Or?
Yeah, I'll show that as well. I mean, like, when I get to the last part, where he was asking what do you do when JavaScript is across multiple files, so I'll show it there, because that's a very practical requirement, right? Okay. Now, if you look at the configuration options here, you can see there are a bunch of them. There are about 7 of them. I've already explained source returning methods and sync returning methods. I'm going to explain 2 more, which is argument assigned as a source and argument assigned to sync methods. I'm going to explain what these 2 are and in what context they actually come in. Okay. So this page is also vulnerable to DOM-based XSS, and when we look at the source code, what it does is there is a function being declared called as doEval. Whenever any parameter is passed in, it basically calls the eval method on that specific text, and there is this line where the doEval method is being called with the parameter h, and h is location.hash, right? So this line, it must be highlighted in red. Okay, so now let's put this in and see what actually happens. Okay, so you can see there is nothing in red. You just have a line in pink, which is for sync, and 2 other lines in purple, which is for not purple, maroon, which is for source plus sync. Now what we would have to do is, now here what we see is this doEval function, right? It is calling the eval method, and the value that is being passed into the eval method is the parameter which was passed into the function. Okay, so now the parameter that we pass is being assigned to a sync, correct? So what you do is you go to the configuration, and there is this list saying argument assigned to sync methods. So in this method, since the argument is being assigned to the sync, so you would put doEval under this context, as this is a method where the argument is assigned to a sync. And let's do the trace again, and now you can see that the actual line where you have the problem is being highlighted in red, because now it takes in it knows the context of that specific function, right? Okay, and I have one more, which is, okay, this page is also vulnerable to DOM-based XSS, and let's see what this looks like. This is a slightly convoluted in a way, a little tricky to understand. So there is this function called as assign name, okay, and it takes an input parameter, and whatever is passed in as the parameter, it assigns window.name to that parameter. Okay. Now window.name is a source. If this, okay, window.name is stored in n, and in this line, n is assigned to property, which is the parameter that was passed in. Now n is a source. If property is a sink, then you actually have a DOM-based accessor on this specific line, because then it would mean the source is being assigned to a sink, right? So this function again is of interest because the parameter which is passed in, the parameter is assigned a source, right? The parameter property is being assigned a source, window.name. So okay, let me copy this. Let me put it on the static analyzer. Okay, you can see that this line is being highlighted in orange, which means that in this line a source is being used. So now I see that the property which has been entered into the function, the source is assigned to that property. So now what I do is I go to the configuration settings, and here I say argument is assigned a source. The argument that you pass in is assigned a source to. So the name of the function is assign name. So I'm going to enter that function here. And then do a trace, and you can see, this line is highlighted in red, because now it, takes that thing into account, and it looks for the actual context, and it finds that, this is a problem. So this is, these are things that you would have to know so that you can configure the list of sources and sinks properly, so that you get the best use out of the tool, right? And most of this assignment, I plan to do it automatically, in the sense when you have a bunch of, when you have a JavaScript page and there's a function declared and there's sources being returned, then I plan to detect it automatically and add it to the list of, the corresponding list myself. But that might probably take, a few weeks to a month, depending on how things go, and depending on how easy or difficult it is to implement, So, but for now, this is how you can, kind of work around it for now, right? Okay, any questions this far on like the actual configurations of the the analyzer settings and all that? Okay, all right, good. So I probably think I'm either doing a very good job or a very bad job, because if I was in between, I would get some questions. Okay, I'm going to assume I'm doing a very good job, right? Okay, now we come to the very last demo, and this is a very practical scenario, and this was something which Bish asked and Mark asked as well. What do you do like when you have a regular website? All your JavaScript is not put in one single place, right? You have script source, script source, script source, and your JavaScript is spread across multiple files. And you could have a method declared in one of those files, and that method will be called in another file, right? So you have to take all of that into account. And the examples that we have seen so far are cases where we had the entire JavaScript in one single file, right? So we'll basically look at how you can handle scenarios like that. Okay. Now this is again a page that is vulnerable to DOM-based XSS, and let's look at the source code here. It takes in two JavaScript files, source returned.js and sync assigned.js, and these are basically two functions. These are functions which I've used in previous examples, right? So this is one JavaScript function which returns a source, and this is a JavaScript function which whatever you pass in as an input parameter, it does an eval on that, right? And finally, there's a bit of JavaScript code on this HTML which is basically calling these two functions. So now when we do an analysis, we have to analyze all three files, that is the two JavaScript files as well as the HTML file, and we would have to do it in order, in the sense we first analyze the first one and then the second one and then the HTML file in that specific order. Now to do that, to figure out which page loads how many JavaScript files and those and things like that, what you can do is you can use the proxy component of the tool, right? So I don't know why this thing is okay, because my screen is shrunk. This thing is moved here. So there's this option which says set as system proxy. So when you do that, traffic from your Internet Explorer, Chrome, and any other browser which uses the regular IE settings will be redirected through IronWASP. Okay, so I've configured IronWASP as the system proxy, and I go in and I do a refresh here. And if we go to the logs, you can actually see the logs being generated. This is the HTML file. These are the two JavaScript files, and I'm not sure if something is wrong or. Okay, what will usually happen is, to answer your question, I've got a plugin called as DOM XSS scanner, right? And this is a Python plugin, excuse me, which uses a regular expression, and these are regular expressions written by Mario. They are available on the DOM XSS wiki. So I've taken this regex, and on every file which passes through the browser, through the proxy, that is, this regex is run, and it would show up in the test lead section. So when you go into that, I mean, it's not showing up in test leads now, but it would put up information this way. When you click, if it shows up in test leads, and when you go there, it will tell you, these sources and sync regex were matching. So you would know on which page, if there was any source or sync at all, right? So that's how you identify if a page has a source or a sync, so that you can, if there is a source or a sync available, you can right click on that and say select for JavaScript testing, and that would come here, and then you can do a static analysis on that. Okay, that is one part of the picture. The other one is, even when you have identified that there are 5 different files which have sources and syncs, now you have to know which HTML file has which JavaScript files that it loads. You have to get that correlation in place. So to do that, okay, to do the correlation, as to find out which HTML files load which JavaScript files, what you can do is you can use a little log mining script, right? So this is a small Python code which you can actually use for doing this correlation. And the thing with IronWASP is it comes with an inbuilt scripting engine, right? So in the logs, you can see under the tool basically logs every traffic that goes through it, be it the scanner or the crawler or whatever it might be. So we have these logs under the proxy logs, and what I can actually do is, from the scripting shell, I can I say session.fromProxyLog, and then I give the log ID as 1. The log ID here is 1. So when I do that, what happens is that specific session, both the request and the response, which was stored in the log, is taken in. It is passed in as a IronWASP request and a response object, and I basically get a representation of that log as an object in the scripting shell, right? So I can basically do all my analysis on that. And IronWASP actually has a lot of simple APIs to pass through the HTML and stuff like that. So if I want to get all the script elements with the source attribute, it's a one-liner. So I say s was a session that we pulled from the log, s.response.html.get values, and I say the tag name is script, and the attribute name whose value I want to get is source, src. and it gives me a string array, which has all the JavaScript source files, right? So what I have done is I have written this into a simple script. So this was the interactive shell. You can go to the multi-line shell, paste the script, execute it, and it'll print this correlation. So HTML file and the JavaScript files which were pulled in on that specific HTML file. If you have a big log, it'll like print a big list of HTML or the parent page and all the source files which were inside that specific parent page. So what we can see is in yeah, it does support XPath as well. See, this is the API for the tool, and the HTML. Okay, HTML property of the response object is basically this class, this HTML class, and it's got like a bunch of methods, and the one that I'm using is get values. This is the method that I'm using. So you have documentation right there, so you can, there's a bunch of other ones. There's one called as query nodes and query values. This will take an XPath query, So for these, what I've done is I build the XPath myself, and then I call these methods internally. But if you're good with XPath, then you could directly put the XPath in and you can query it. So not everybody knows XPath, so they can use this ones because they're much easier. If you know XPath, then you can use the full power of, you can do querying much easily. So you have that capability as well. So you can just explore the API from here. It's kind of handy. It is right next to the scripting area. Okay. This is the entire IronWASP API. No. This is the entire API available from IronWASP. This is the entire API documentation tree. It has like all the classes. So you can refer to it when you're writing your script.
So, is it same across Python and Ruby?
Yeah, it's the same thing for Python and Ruby, but there's a slight difference in terms of naming in the naming structure. What I've done is in Python, for example, get values is capital G and capital V, right? So if I go into Ruby and in HTML in methods, get values is lowercase get underscore lowercase values. So that's the only difference. The actual names are the same, the structure is the same, because everything is internally calling the same .NET APIs, which I've written in C#, right? Just the naming structure is different in Ruby. It is all lowercase with underscore. In Python, it starts with an uppercase and no underscore. Don't ask me why it was done this way. I mean, Ruby. I had a lot of trouble porting Ruby here. Python didn't complain at all. Python was happy with whatever I threw at it. But Ruby had, I don't know. I mean, Ruby was like a. Sorry. I think Ruby was like dating a supermodel. It keeps complaining almost every single. Anything you try to do, it'll say overloading, method overloading, for example. Ruby was not supporting it.
Ruby's feminine.
Sorry?
Ruby's feminine.
Oh. Okay, maybe because of that. But anyway. Yes.
So is it running on .NET?
This thing runs on .NET, yes.
Okay.
It's a C# program. It requires .NET 2.0.
Okay, so this Python is actually using IronPython.
Yes, it uses IronPython and IronRuby. And the libraries are written in C#. And this API is simply calling those, that library from Python or Ruby. So if you just read up on the API, then you don't really have to worry about the standard libraries and stuff like that. If you're comfortable with the Python syntax or Ruby syntax, you can simply start writing stuff. And it's got you've got easy reference to the API, and you've got syntax highlighting in the code as well. There is a separate script editor if you want to write like serious scripts. If you want to edit the existing plugins, you can, or if you want to write new plugins, for example, it has a template as well. So there is something for you to start writing plugins with. and the bottom area is for checking your syntax. So if you have a trouble in your syntax, you can do this check syntax thing. If your syntax is clean, this bottom area would be white. If you have trouble in your syntax, it'll get highlighted in red, and it'll tell you in which line you have what problem, right? So it's easier you don't have to depend on a separate IDE. You can write your scripts and plugins from within IronWASP itself, right?
For these plugins, if I write it in Python,
Mm-hmm.
and if I need to manipulate Ruby,
Mm-hmm.
so how is it done? Or do I have to write again in Ruby?
You mean you write a Python plugin and you want to call it from Ruby?
Yeah.
Okay.
If I want to actually have that APIs available in Ruby.
I don't get it.
So consider I'm going to write a plugin which has
Right, okay. Let's say XSS, for example.
So I'm actually writing it in Python. Python APIs.
Mm-hmm.
And so if I want to actually run that particular logic, let's say in Ruby, in a Ruby code, so do I have to run the whole thing in Ruby?
You don't have to. The thing is, if you look at the plugins that are actually available, guys, I'm just taking a slight detour from the actual JavaScript thing here. Forgive me for doing it. If you look at the plugins that are already available, okay, let's look at the passive plugins. These are for passive checks. When traffic is going through the tool, it will passively identify vulnerabilities. And there are both Python as well as Ruby plugins available. So it's not like you have to have both Python as well as Ruby. What you can do, like what happens is whenever you write a plugin, be it Python or Ruby, it gets converted into a .NET object. Okay? So this specific plugin, for example, Nexus is written in Python, but then from the scripting shell, you can go to the Ruby thing, and you have an option. XSS is an active plugin. Okay? There's a method which says active plugin or get, you have to get the plugin. So if you go here and say active plugin or get XSS, it will return the plugin object. And you can call the methods of plugin object. That's the Python plugin. But you can call those methods from the Ruby shell. Because everything gets converted into the .NET, into a common .NET object. So this interop between Python and Ruby is not really a problem. So I hope that answers your question. Okay, cool. Okay. Right. So going back to the topic that we were discussing, that is when you have multiple JavaScript files being loaded in a single page, what do you do? What you can do is you can run the script which I just showed you. This script will print out each file along with the JavaScript. The other JavaScript files that are loaded in that specific HTML file. And now it comes to the manual part. Now, multi-page.html loads source written.js and sync ASS.js. You have to go to my logs, and first I'll say do a select this for JavaScript static analysis. I'll do that. This is the get hash method, so it returns the source. So I've identified this. So I'll go here and say source return in the get hash. So I've analyzed one file. Now the next one is sync ASS. I'll go to logs again and say sync ASS, select JavaScript testing. You can see the parameter being assigned to sync here. I'll say argument assigned to sync. Okay, so I've covered these two. I've covered both the JavaScript files. So now it's time for me to analyze the primary file, the HTML file itself. I'll go to log, I'll select that for static analysis. And I'll do a trace. And you can see, if you look at the source of this file itself, the HTML file. Yeah, so the actual JavaScript side is just two lines. One is the get hash method, the other one is the do method, and none of these are sources or sinks. But since we have analyzed the other JavaScript file, since we have updated our source and sync list accordingly, this thing highlights, the knowledge XSS vulnerability. It tells you in line number 2, you are actually doing, you're screwing things up, right? And one is when you click on a specific line, which is highlighted, you have a little bit of information which pops up underneath. It will tell you on what basis it thinks that line is the source. It could be obvious when the actual source of, let's say, the location is being assigned on that specific line, then it would be obvious. But then if location was assigned to a different variable, that variable gets assigned to another variable, that gets assigned to another variable, and then that gets assigned to another variable, then it will still be highlighted in orange, but when you click on it, it will show you the whole list. It will say this was used first, this. So you can actually, it's like a trace. So you can figure out that okay, this is why this is highlighted as a source, right? And another neat trick is you can actually right click on any of the lines, and if you feel that that is not actually a source or that is not actually sync, you can say remove source sting. So now that line is not being considered as a source anymore. So H is not a source. So this line is not a normal XSS. So it only highlights and picking because it's sync. The same way is a line where there is no highlighting, but you feel that that line has a problem. So then you can say set source state. So now the line will be considered as a source according to the rest of the analysis will also update itself. Right?
So does it automatically configure that lane configuration?
When you do it from here, it doesn't. But it's kind of hard for me. I would want to do that, but then, like I said, I don't really know when I would be able to do it. It all depends on how difficult it turns out to be when I actually try to do it, right? So, but then, yeah, that's a good idea. I would do my best to kind of pull it in. Right. So that was it. If there are any other questions, I guess I've kind of crossed my limit here. So you guys can catch up with me outside, right? All right. Thanks.